and this was always soluble. All we really had to worry about was that. And then we had to just check and see which one of those were an exception, if they were exceptions. Right? It's possible that they weren't exceptions, but in this case, it was. Okay, good job. Ready for the next one? Which of these compounds contains the most hydrogen by mass? No, never mind. C2H 2 times 2, 4, 5, 6. Oh, there we go.
Here's a question asking which one has the most mass percentage.
Yeah, which has the most hydrogen by mass?
It's a math problem, right?
Yeah. Which has the most hydrogen by mass? If everybody knows how to do this one and it's just busy work, you can tell me. Is it? You know how to do it? Tell us how to do it.
You're going to find the mass of all of them and then find the percentage of hydrogen in all of those and then see which one has the most.
Can you just
Count them up.
yeah, CAH18?
Why doesn't that work? Why doesn't that work to just count them up?
That doesn't work.
Well, I don't know. Maybe it does. Let's see. Maybe it does. Okay, let's see this one here. We got a 12 from the carbon. We got 4 from the hydrogens and 16 from the oxygens. Didn't we just deal with stuff? Is that 32? No, that's just 30.
32 plus 4.
Oh, 32. 32. Okay. This one is 12 times 8 plus 8. What's that? 8 what?
Yeah, they times it.
Oh, plus 18. 12 times 8 plus 18. This one here is 24 plus 6 plus 16. 30, 46.
Wait,
What?
why does that one 12 times
Because there's 12 of the, or 8 of these carbons. Each carbon's 12. Is that right? Did I do that right?
Yeah, here.
What's the answer for this one?
114.
114? 114. So 18 over the 114 times 100 will give me the percent hydrogen. This one here is 6 over the 46 times 100 will give me the percent hydrogen. This one is 4 over the 32 times 100 will give us the percent hydrogen. Which one is the answer? The middle one? What percentage is it? 15.8%.
So, could you not just count the...
So let's try this one then. C10H22O. Does that work as well? Can you just count them up? Actually, I'll throw in a couple more oxygens. I know what 12 times 10 is. 120 plus the 22 plus 16. 16 is 32. 32 plus 16 is another 16. 48.
It's only 11.6%.
It's only what?
It's 190.
190? So 22 from the hydrogen. 22 divided by 190 equals, or times 100. And you said it was 11 point what? 6%? So you can't just count it up. You still got to do the calculation. Any questions on that one? Mm-hmm. Okay. If I'm going to combust 2 moles of this stuff. How many moles of oxygen do I need? Oxygen gas are required to combust 2 moles of my favorite stuff. Okay, how many moles of oxygen are required to combust 2 moles of that stuff? How do we solve that problem?
When I say the question, I'm not sure where to start.
Do you guys know where to start?
Is that a 22?
A 22, C10, H22O3, that's right. Any ideas? Any ideas?
Is it to just to be equal sign in the line?
I think that that's going to be okay for us. Moles of oxygen gas to the right, right? 2 moles of C10H22O3. That's a really good place to start.
Do you usually have a value here though? Yes, you do.
Oh. Are required to combust that.
What do you got there now?
Um,
You're going to grams?
that's why I got confused. Because the grams don't make sense.
Okay.
Because we're trying to go to the moles.
Yeah. I think we can just go stay in the land of the moles, right? Because all we want is moles of oxygen.
So straight to moles of oxygen then?
I think so. Can you do that? Do you know that relationship? Hmm?
So 1 mole creates 3 moles of oxygen.
Yeah. Can we do that? How?
We don't know like what it results in.
What the products are?
But other like, yeah.
Okay. Okay. So she just told us something important. We don't know what the products are. Or do you guys? You guys know what the products are over there?
No.
Is there any way we could tell based on the question?
No.
Oxygen,
Oxygen is what?
the react.
Yes.
Yeah, oxygen is a reactant. I know that. Is it true that I know C10H22O3 plus O2? Do I know that much from the problem? What are the products? Are they looking like that you might know? Here's a fancy word. What does that mean? Combust.
Carbon dioxide.
That's right. Carbon dioxide is one of the products. What's the other product? H2O, very good. Just came to you, right? H2O. So carbon dioxide and water are the products of our combustion reaction.
So the other things aren't in it?
What other things?
Or do you just need to balance it?
We just need to balance it. So all you need is the balanced equation, and then you can see the ratio of these
But you want
to
2
this.
moles of that, right?
But we do want 2 moles of that. That's a little sticky thing at the end there. Did you already balance the equation?
No, I
Oh,
just
okay.
asked.
How long are we going to do this? 5 hours, really? No. You're going. Any luck? Did you balance it? What'd you get?
10.
10 of these?
Yeah.
Holy mackerel.
You can only have 2 of those, right?
No, I don't know. What's the balanced equation? We just want the balanced equation. Huh?
10, 16, and 20, and 22.
22? All those values are even.
I did.
5, 8, 4, and 11?
Yeah, that's what I meant.
Okay. Good. Anybody else get that? No? Did you get something else?
No, I just know. This is still working.
You're still working on it.
So I had like the 10 in front of the
Yeah.
C2 and an 11 in front of H2.
Okay.
So that is, and then a 14 in front of the oxygen. Does that work?
Wait a second. Oh, this isn't 10. This isn't 4. This is 10, right? I just divided it by 2, so this should be 10. 10 and 11, right? And then what did you say? And did you get the other ones yet?
I put the oxygen in front of the O2.
The 16 or 14 in front of the O2?
Yeah, 14 in front
But
of
you
the
can
O2.
reduce it down.
And that's all I added was the 14, the 10, and the 1.
So this is 20 oxygens, and this is
Oh,
31. So here you need
Wait.
that's right. I don't know if I put it. Here. let me-
28, 29, 32. Well, that should be 14.
Is that right?
I don't know.
I don't think so. Wait, hang on.
Is this 14?
I have so many questions. Why are it's numbers?
Well, I'm just putting numbers that people told me.
So if we like what? Do you want the simplest form?
Yes, of course.
Okay, so it's nothing on the first one. 24 is 14 for O2. And then 10. Minus,
That's what you said, right? Okay.
yeah.
Okay, very good. Then, what's the answer? How many moles of oxygen are required to combust 2 moles of my favorite stuff?
14.
Close.
Shoot, I don't know.
Like 10 seconds ago.
Would it be 28?
28. 28. Because 14 is for 1 mole of this, apparently, right?
Oh,
So, 2 moles. Okay. Very good. Right. Okay. Let's do one of these box ones because sometimes box ones bother people. I like them.
oh, the particle mixture
Yeah. So,
compounds.
well, let's try this again. There we go. That's beautiful. Okay. Okay, can you match up these with their boxes? Obviously, one's going to be left out. But can you match up those with their boxes? Oh, wait. Let's try one more thing here. I'm going to make this that. There we go.
PVI is the first one.
The first one on the left here?
Oh, yeah, this is like solid, it's
Hmm?
like those two ones together.
Right?
That's like first.
Or is it solubility?
Could be have to do with solubility. So, do any of these help you know something about them or anything?
Acids.
Which one's an acid?
The bottom one.
The bottom one here?
Right? Bottom two?
Bottom right?
H.
Bottom middle, you mean?
Yeah, the bottom two.
Bottom two. Okay, these are acids, that's right. So what do they do when you put them into water?
H.
They will dissociate and release the hydrogen ion. Some dissociate more than others, right? The ones that dissociate completely are called what?
Strong electron.
Strong acids, strong acids. Is this a strong acid? No. Is this a strong acid? Yes. Okay, so which one would look like a strong acid up there? Far right. Good. So there's our strong acid. What does our weak acid look like?
The second one.
Second one. Good. What's PBI? It's, what kind of compound is it?
Insoluble.
It's insoluble. Very good. It's a insoluble ionic compound, right? Which one of these would represent what an insoluble ionic compound would look like? This one here? Or no, this one here? What did you say? How do ionic compounds reside? Are they paired up like this, floating around as their little friends? They are what? What do you call that? A three-dimensional lattice, right?
It only the person with water was able to break them up here.
Yeah, so maybe something like this. Nah, that doesn't exist. A couple of these don't exist, but that's all right. NF, right? This is not an ionic compound. It's not an acid. So, but if it was soluble, it would reside like that, right? Because it's a molecular compound. Okay, good. So this here is the example of our, it really should be PBI2, but it's an example of our insoluble compound, right? It resides as an insoluble ionic compound, resides as a three-dimensional lattice. Okay. So I think it's my turn to go, but I've circled some problems in here. If you want to keep going, working on some problems. So, at the end of chapter 4, everything is circled in black.
Okay.
And, you know, you can work on other problems as well, but
Which chapter does this test go to?
1 through 5.
Okay.
I think that's good enough to review.
All right.
Does that make sense?
Yeah.
Okay. Yeah. What's your story, Walt? What you doing?
Playing chess.
What's that? Playing chess? You want to play chess for another couple hours or not really?
Oh, let's go.